So welcome you all. Today's topic is principle of quantum mechanics, and we will also discuss some postulates of the quantum mechanics. So the subtopics which we are going to discuss here with is quantum mechanics, its principles and postulates of quantum mechanics. So here we are coming with the quantum mechanics or wave mechanics. As you know, the laws of quantum mechanics were formulated in 1925 by the German physicist M. von Heisenberg and P. Jordan, and in 1926 by the Australian physicist E. Erwin Schrödinger. So these are who has given the laws of quantum mechanics, and especially here we will also discuss a video with the help of video to understand the laws or explanation given by the Werner Heisenberg. So the Schrödinger formulation of quantum mechanics is more familiar to chemists than the Born Heisenberg Jordan formulation of matrix mechanics, though both the forms are equivalent. So here if we see, the both forms are equivalent, but here for especially for in point of chemistry we will be more focused on Schrödinger formulation. So as you know, in the principle of quantum mechanics is helps to understand the nature of electrons, and the particles. The Werner Heisenberg has given the concept the position and momentum cannot be found precisely simultaneously, and it could not be found simultaneously, which was the important concepts given by the Werner Heisenberg. So that is called different at a positions, and in his theory precisely it cannot be uh, can be explained. So the Schrödinger formulation of quantum mechanics is more familiar. So here if you see, in 1928 PM Dirac, the British physicist, formulated his celebrated relativistic quantum mechanics and showed that the electron spin emerges as a natural consequences of his theories, wherein Schrödinger non-relativistic quantum mechanics, it has to be imposed later. So the quantum mechanics in a particle in a box in three-dimensional space can be found by or can be observed by the Schrödinger wave equation. So the Dirac theory, it has become indispensable in the physics of elementary particles whose velocity approaches that of light when accelerated in a cyclotron and other high energy accelerator. So this concept is more realistic towards once we discuss in a physical concept of the bodies. So once you see, now we shall dwell on the reason why the Heisenberg uncertainty principle forces to abandon Newtonian mechanics. We know that the motion of one particle, one-dimensional classical system, is governed by Newton's second law of motion, that you all are aware that F equal to ma, or it's in a form of this force equal to mass upon acceleration. In order to obtain the position as a function of time, this differential equation must be integrated twice. So this can be integrated twice with respect to time. The first integration yields dx upon del t, and the second integration gives x. Each integration, however, introduces an arbitrary integration constant. Hence the integration of f equal to ma gives an equation for x that contains two unknown constants c1 and c2. Thus we have, these are the unknown constant C1 and C2. So x is the function of t time C1 and C2, where f is a function with respect to this equation. So if we know that at a certain time to the particle is at the position x and so has a speed nu naught, then C1 and C2 can be calculated from the equations. So x naught equal to f t naught C1 C2 and nu naught equal to f t naught C1 C2. So where f is the derivative of function f. So this f prime, especially this is the f prime, is the function, is the derivative of this f or this function. So thus if we know the force f and the initial position and velocity or linear momentum of the particle, we can use Newton's second law of motion to predict the position of particle at any future time. The same argument holds for a three-dimensional particle system. So similar concept or the same argument holds for a 3D particle system or three-dimensional particle systems. Here in classical mechanics, the state of a system is defined by specifically for all the force acting and all the position and velocities of the particle. Thus, as said above, a knowledge of present state of classical mechanics system allows its future state to be predicted with certainty. It is at this stage that the Heisenberg uncertainty principle comes into the picture. It shows that simultaneous specification of position and momentum is impossible for a microscopic particle. So when this principle or this concept, which the experimental observation by the Heisenberg uncertainty principle come into existence, and on that basis for the microscopic species it is not able to specify concisely or precisely the position and momentum of a particles or electron like particles. So hence the very knowledge needed to specify the classical states of a system is unobtainable in quantum theory. The state of quantum mechanical system must necessarily involve less knowledge about the system than in classical mechanics. So in other words, the certainties of classical mechanics must be abandoned in favor of the uncertainties of quantum mechanics. So where it is in classical concepts there is certainties, while in case of when you discuss about the microscopic species like electron or small electron proton particles, then there is a uncertainties to is as observed and given and observation given by the Heisenberg in his uncertainty principles. So the classical mechanics is deterministic theory, because this is only being applicable in classical objects or big object or macroscopic objects, while you comes to the in contrast quantum mechanics gives the probability of finding the particle at various location in space. So if you see, it allows us to predict the exact path taken by the particles of the system, because this only gives about the particles at a specific or definite, it allows it to predict the exact path system and tells us where they will be at a future time in the contrast. But this does not happen with the small or microscopic species of particle, because it gives only the probability of finding the particles at a various location in space. It means you cannot easily find out the electrons at in a particular positions, because this could be in a space, it could be only a probability you can see the electron cloud. In electron cloud the electron would be in that particular position. So as we shall see shortly, in quantum mechanics, the state of the system is defined by the state function or wave function, which is represented by psi, which is a function of coordinate of the particle of the system and is also a function of time, since the state may change with time. Thus, for a two particle system, we have a wave function can be written in a form of psi equal to function of x1 y1 z1 and x2 y2 z2 at t. So where x1 y1 z1 are the coordinate of particle 1, etc. for an n particle, and similarly for an n particle it can be n number of particles can be there. Now the equation governing the time dependence of psi is given by the Schrodinger wave equation, is well known Schrodinger wave equation. Here summation minus h square upon 2 mi del square psi upon del x square and del square psi upon del y square and del square psi upon del z square. So here where mi is the mass and v is the potential energy of the particle. So the above said equation is time dependent second order differential equation known as the Schrodinger wave equation. So by this, so now the postulates of quantum mechanics. So what were the postulates? There are total 6 postulates which has been given in quantum mechanics. So the formulation of quantum mechanics or wave mechanics for the wave mechanical treatment of the structure postulates which for a system moving in 1D. Here there are stating from postulate, first postulate. The postulate first states that the physical state of a system at time t is described by the wave function r given by psi star xt. So this is the complex coordinate of the psi, and here x with respect to time t. So psi is the wave function and its first and second derivatives. If you see, in case of second postulates, the wave function means once you are going to the second wave postulates, the wave function psi xt and its first and second derivative del psi xt upon del x and del square psi xt upon del x are continuous, finite and single valued for all values of x. Also the wave function psi xt is normalized wave function or normalized wave function. Here that is can be represented as from minus infinite to infinite integrated integration psi star x t and psi xt del or dx equal to 1. So this is stated the second postulate of quantum mechanics. So there are, if you see the here psi star is the complex conjugate of wave function psi. So psi representing wave function, so this is the complex conjugate of psi. It means wave function psi star is the complex conjugate of wave function psi. Third postulate, if you see here, a physically observable quantity can be represented by a Hermitian operator. A physical observable quantity means any physical which can be observed, any quantity is can be the quantity which is observable is can be represented by a Hermitian operator, and an operator A is said to be Hermitian if it satisfies the following condition. So any operator which is will be said as a Hermitian if it satisfy the following condition. So here you can say integration of psi I star, it is a complex conjugate of operator A psi j del x equal to psi j operator A psi I star dx, where psi I and psi j are the wave function representing the physical state of the quantum system. That is a particle, an atom, or a molecule, where it could be the particle, an atom, or a molecule. So this can be represented, or this can be explained with the help of this third postulates of quantum mechanics. So here this is the final form, because for you can also we can see in a detailed form of expression, but for the sake of understanding here in chemistry, it is enough to be kept in mind the final form of these postulates. But for in details in quantum physics, there is the overall derivation is there for each and every postulates, their application as well with different systems. So here now if you see, this is representing the physical state in a wave function, representing the physical state of the quantum state. So fourth postulate, the allowed values of an observable A or operator A are the eigenvalue in the operator equation. So operator A psi I equal to AI psi I. So this is the fourth postulate, which is, if you see, this is operator A psi I equal to AI into psi I. So this is the fourth postulates represented by this equation for the quantum mechanics. So the quantum mechanically, it is operator multiplied by psi A, which is the wave function of I entities, and AI is the multiplied by the wave function of another psi I entities. So here overall, if you see that there is the specific relationship between these operator with respect to different particles. So equation 3 is also known as eigen equation, which is we just seen. Here operator A is the operator for the observable physical quantity, and psi I is an eigen function of operator A with eigenvalue AI. This is the eigenvalue for with an eigenvalue AI. In other words, measurements of the observable A yields the eigenvalue AI. So this is especially it is observable in case of is the operator for the observable physical quantity. If you see the equation third, which is just above, so here it is known as the eigenvalue equation. So by that way, this can be observable for the physical quantity. Here if you see the fifth postulate, which is being given, the average value or the expectation value is A of an observable A corresponding to the operator is obtained from the relation by this fourth or equation fourth. So A equal to integration in minus infinite to infinite psi star operator A psi del x. So here the wave where the function y is, where the function is assumed to be normalized. This is psi. Actually psi is a assumed to be normalized in accordance with the equation 1, which we seen in earlier. So here thus the average value of say the x coordinate is given by this equation. So here the other like wave function x, and it is for in a specific coordinate can be represented with by this equation. And once you see as per the fifth postulates, it is for corresponding to as per the equation 4 obtained by this relation. So these are expectation value of observable for the like A, where in case of the wave function in normalize accordance with the equation 1, thus the average value of the say the x coordinate for the x coordinate is given by this equation. Now the sixth postulate of quantum mechanics, the quantum mechanical operator corresponds to the observable are constructed by writing the classical expression in terms of the variable and converting the expression to the operator. It means the quantum mechanical operator which corresponds to the observable are constructed by writing in the classical expression in terms of different variables and converting the expression to the, and those variables is converted into the expression to the operator. So if you can see from 1 to 6 postulate, so these postulates are the different for different wave function and their complex coordinate wave function. These postulates can be seen with their different expression for each of the postulates. So here if you see from the overall discussion, we had seen from the classical the principles of classical mechanics and quantum mechanics, and that we discuss in details, and the classical and quantums has been also seen by the experiments from in a form of videos. We seen that uh, the experiment which is done by the Heisenberg, which is called Heisenberg uncertainty principle. So in case of Heisenberg uncertainty principles, it means the particles position and momentum cannot be could not be non-simultaneously. And you also see from there the proton is in the having the highest mass compared to electron. If you see, this is having 2000 times more mass with respect to the electron residing in the teeny space which is called nucleus, and electrons which makes the you know makes the cloud of electron cloud around the nucleus. And these electrons are ones is having the maximum probability of from finding the probability of electron from the nucleus is maximum at a certain level or certain distance, which is a Niels Bohr orbit or the radius of the nucleus, where the maximum possibility of finding of the electron is possible. And after that there is it's declined the probability of finding the electron. So it means when these electrons get absorbed certain amount of energy, they excited in different level of higher energy levels. So once they absorb the energy, so they produce different spectra, absorption spectra, with having different energy in a form of different color. So once they comes back to their original ground state, so during that process they emit the photon, which gives the basis of emission spectra. So that makes the absorption and emission spectra. So here you can see the references for in details for your understanding, and thank you so much for your patience.